Here are 9 Rust best practices I'm using when building a library. In the first episode, we saw the first 3, and in this one, we will talk about the Utils best practices, including the extension trait pattern, examples, and tests. And we'll still use genai as a real example. Okay, so first let's talk about the utils. So for utils, I'm using 2 terminologies. The first one here is going to be utils, and that is going to be for things that are shared outside of the crate. So for example, that will be something like source utils mod.rs. And then I will put all my utils below that. And then typically in the source, the mod.rs, I will have a pub mod utils, as we can go down. Now I'm going to talk about that for libraries. If we can avoid those, that might be pretty good. I'm going to talk about that later. But one place where I use it a lot is when I have a multi-crate project, a workspace, a cargo workspace. Then I often have crates, lib utils, lib.rs. And then I put within the lib utils all of the utils that I want organized by function, base64, UUID, and so on and so on. And those I can reuse them in all of the other crates. And that is very useful because first it removes some of the common code, and also it normalizes behavior across all of the crates. So for example, when you are using UUID, you want to use it one way, and you don't have to expose the whole UUID crate to everybody. So that is a nice way here of doing this when we are multi-crate. Then the other terminology I'm using is support. And the two have the same function, is to provide utils to a code base. And that is private to the crate or the module. And in fact, it's more about the modules than anything. And then obviously when it's the root module, it's for the crate. And then the example of that will be, and we're going to see in genai here how it works, is we have the source support.rs. If it's small and I can put everything in one file, or if there is more utilities, I have the module name, and then I have support mod.rs. So that's the 2 options here, depending if it's just a couple of a function, or if it's more, then I put it and organize it like that. And that is really private to the crate or the module. So one example here, we can have a source adapter support.rs. Or it could be this one as well, obviously. And that will only be accessible by my code design inside the adapter. So like this, I can have different levels of utilities in a way. And when I see support, I know it's a subnet space support of whatever the module it is. And it's private to this module structure here. So I start here, and then everybody below can use it, but people above cannot use it. So let's see how it works by example. So if we go to our genai, lib.rs, we see that the first thing that we have is a support here. So I have a mod support, and that means that will be private to where it is defined, which is the root of the lib.rs, which means that everybody below the root can have access to it. So as long as something within support is public, then it can have access to it. I used to have also a pub mod utils here to follow the pattern that I was discussing before, but typically for libraries, we want to avoid that because in many ways, what our library is about being a utility for something. So having some utils here, pub utils, will be a little bit odd. And this is why I use 2 different names, because just by looking at my library, at my code, at the code structure over there, I can see that I have support. So that is my internal cooking, my private utilities, but I don't have a public utils. Now let me show you what I had before and how I changed it and why. So in genai version 0.1.5, I had this pub utils over there at the beginning, and I have my utils over there. And that again, this means that utils is at the root, and by my convention, this should be exported. And if I don't want to export, I put it in support. So that again is the best practice. And again, some other module can have support over there. We'll see that later. But the point here is that here I decided to put the pub mod utils because I had this kind of printer, chat printer, which was not really a core function of chat and everything. It's more like utilities for debug. And I didn't want to have a feature or whatever. So that's why I did it this way here. And so we can see the function here. It was just print chat stream and then those guys. And I think I flattened them out over there. And I cherry picked them to make sure that it was clear what I was exposing. And that was fine, but it was a little bit kind of a stretch because now follow this potential anti-pattern of trying to have a utils, it was not really needed. So now in the latest version, 0.16, 1.7 and on, I remove the pub utils, so we don't expose that, and I put it inside the chat. Now I have the chat, I have printer over there, and then I have the mode printer, and this one I'm not flattening it out, I'm just leaving the printer like that. So when I think that utils is kind of the exception for libraries, it might fit in some case, but it's more the exception than the rule. I do think it's a very good best practice for when you are doing a multi-crate project. Let me explain. So I'm going to show you the awesome app, the future awesome app, which is going to be open source mid-end of August. And this is a multi-AI provider desktop application written in Tori. It's pretty cool. But the point here is that because it's a relatively big application, I like a lot the multi-crate approach, and that allows our code to scale very well. And for those type of application, there's always kind of a crate that I have, and I often prefix the one with lib. It's a little bit redundant, but it's very clear when we import. And I have often, if it's not all the time, a lib-utils. And that is the base utils that I'm going to reuse in all of these libraries. So for example, I didn't put in utils the thing about the RPC. That has its own library. But things that are more low level and basic, I put it inside lib. So for example, if I go into lib-utils, we can see that we have the things for base64, environment, handlebars, some macro utilities. And then we have our trait extension pattern here that I will explain later. And then our UID. And if we go to lib, I re-export them, I don't flatten them out, because I want them to be mostly usable independently. So I don't even have a common error. And in many ways, the one, for example, if I go to base64, this one has its own error. And then because it's so small, I don't want to have a folder with mod.rs and error. So I have the function over there, and I have the error over here. And that allows also for me to normalize the type of errors that I want to support or to express in my application, and to not be too dependent into the libraries that I'm using. So here I'm abstracting most of it here. So that's one reason why I do that. And usually I like to have all of those being relatively independent on each other. And so for example, if I go to UUID here, I decided that for my application, when I create a new UUID, I want UID v7 of now. That might not work for everybody. And the API of UID is very cool because we can do whatever we want. But I don't need to expose this flexibility everywhere. I want to normalize it. Now I have cool kind of macro here. I have another naming convention, which is that is macro to help derive things. It's a little bit of a hack, but for big derive, that can help a lot. This is not flexible, so I'm not saying it's the best practice. I'm still experimenting with that. And then I have some macro helpers here for my S string here. I'm not very proud of this one, but I have that until they have it. And then this is kind of a more experiment for option. I'm not saying that that is good. But the cool things about this is, again, the lib-utils, it's an app, so it's not going to be exposed outside. And it allows me to experiment and have my own little code here. So that is a way that I'm doing the lib-utils in the context of a multi-crate. So that works pretty well. So now if we go back to our genai, we have now the printer over there. So that is, we don't have utils anymore, which is good. And then we have our support. And within our support today, we just have two things, which is a mod.rs that just include the ValueExt. Usually when I have a support at the root, I start directly with a folder kind of things, because I know that that will probably grow. Right now I keep it simple. And then here in this case, we can see that we have a support only for the adapters, modules and submodules. Even inside adapters, I have again a support, and I know by my convention that that is only for the adapters module. Yeah? So this one is this way. It's always like that. I never flatten them out. And then within it, I decide what I want to do. So in this case, I have this little type here that is just used into this one. I could have created a module, streamer_option.rs, that would have worked as well. But in this case, I wanted to put everything in the same one here because I have this other type. And so I didn't want to have too many little things over there. So typically that if it's utils or support, they are always structured the same for what I'm concerned. just that one is more across crates, and then the other one is just within the module. And then after, there's a very cool pattern in Rust, and that is the extension trait pattern. And before going there, let's understand what is the extension trait pattern and why it can be very useful. So first, to understand what is an extension trait pattern, let's have some terminologies. If I start a type with my, that means that is within the same crate. And when I'm going to start a type with other, that will mean that is outside of the crate. So far, so good. So now we can do three things, and there is one thing we cannot do. First, obviously, we can implement my trait for my type. So that is obvious. The second thing that we can do is implement other trait from the standard library or from another crate for my type. And that is what we do when we implement default, from, and all of that. So that is a way that external crate or the standard library allows our type to fit into their model. That is very useful. And the third one that we can do is we can implement our trait, my trait, for other type. And that is what is called the extension trait. And that is because we're taking an external type and then we're extending it with some of our behavior. That is very cool here and specifically cool for utilities. And then for completeness, there's one thing that we cannot do, and that is implementing another trait for other type. And that is because in this case here, in these three cases, the compiler can always disambiguate who is implementing what for whom. But in this case, if two external crate will implement the same trait on the same type outside, we wouldn't have a way to disambiguate things. So that wouldn't really work. So that is a concept here of implementing trait for other things. This is why sometimes we have to have the new type pattern. But in this case here, in the extension trait, we have our utilities as a my trait, and then we can extend an external type. So that is very nice. And there's no other way in Rust to implement another function on another type, but by defining our own trait. So that is a way to do it. Okay, so now we can go back to our genai, and we're going to get into our value extension. So the way that I like to do it is the type that we're going to extend with ext. So usually that is something that is relatively well accepted in the Rust community. So that is common. And then in this case, I like to have the matching file name, which is obviously with the underscore ext.rs. So far, so good. Sometimes I can put multiple extension trait inside the same file. That might be more rare. But sometimes I have multiple implementation of the same extension trait. And for example, I can have a ref string, and ref str implementation of the same extension trait. Now, my second best practice is when I define my trait is a prefix of my functions. So I like to have this x underscore prefix. This way, no matter the name I'm choosing, the likelihood of conflicting with either a function name of the type itself or another implementation of a trait is close to zero. And because it's my internal cooking anyway, so usually I use that only for things that are in support or my libutils when I do multi-crate, then I know that when I prefix the things with x underscore, that is my little utilities. And this way also it helps when you autocomplete, and it's very nice to see if you have implemented this trait extension on this type. Now, obviously, because of the way that the trait implementation work, even if you have a conflicting name, you can disambiguate it with some notations, but then the code becomes kind of very verbose. So obviously the value extension will need to be imported, but usually the IDE, VS Code, Rust Rover does that pretty well, and then I can use my own function. And then, depending on the use case, I have the reference of self. I try to get reference of str when it's just a string. Then in this case, I'm taking a value. So I'm going to take a reference of mute self. So I don't want to have it consuming here. It will not be as fluid as having a ref mute of something. And then also I have a cool insert, which will get a ref mute of self with a name and a value. And then the get is basically a little wrapper on the get that also do a deserialization on of value t. It's just a convenient. The whole thing is to be convenient. And then I also have another one, which is my x pretty, and that allows us to make a JSON value a pretty string. And that is useful for test, or when I do the print debug and everything, is actually pretty useful. So I annotate it, allow unused. Usually I try to avoid those, but in this case it's fitting because I don't want that only for test. I want to be able to use it and have some debug print in some places. So that is my extension trait definition. Now, on the implementation side of our trait extension, some of the implementations can be very simple. So for example, this one, the xGet, is almost like a get, but has a couple of benefits. So for example, in this case, I allow path to be just the property name. So that will be this guy. But if it starts with slash, it will use the CRD JSON pointer path. And so I didn't have to re-implement that, is JSON pointer spec. And that allows me to block a value deep inside the JSON value. That is pretty neat. And then once I have the value, the other benefit is that it will do a CRD JSON from value. And obviously the T that it returns will need to be deserialized on. So that allows me to get a value out without having to do these kind of things. And the way that I use it often is, for example, if I have my data, which is a value, and I get it from a request, I can have my let total tokens, and then I32, I give the type, and I just can do a data xGet. I will have the autocomplete. If I have the autocomplete but didn't import, then I can import it with just command dot, so it's very simple. And then I can say, well, it's actually deep inside, so I'm going to say usage total tokens. And then this one, there's an error that can be returned. And then that's it. Just by doing that, I save this couple of lines, and that makes it much nicer to work with. Now, next cool example is we have the take, which is a little similar to the get, but try to avoid to do a clone. So it uses the value take implementation. So I didn't redo this implementation, but the same logic, and can pass a pointer or the property name. And then I will translate whatever value I get to whatever type is requested. That is the same thing that I avoid to do a clone. Now, one thing I might decide later, or as a team, we might decide to say, well, we don't want to do the value take, because value take, what it does is it takes the value and put a value new where it was. So it doesn't remove the property from the parent, from the container value. So perhaps the strategy that we want is find the container. So that will be mute self if it's a property name. And if it's not, is a parent of the path, and then just remove the property altogether. So that would be a different implementation strategy. But in our case, we know that we don't really care to know if the property name was there with a value null is not something that matters anyway. So that would be an implementation details that none of my other code needs to worry about. And then I have a cool one here, which is the xInsert, which allows me to insert in ref mute self, obviously, the name, which also can be a path. So that should be renamed path to be consistent. And then the value, whatever serialized into T. I like to use generic in those functions because they are utilities. And yes, it would generate a little bit more code. But if that becomes an issue, I can move all of that into an inner implementation and then just do the into there. So that would be valid as well. But the point is that from an API standpoint, this is very flexible. And then again, I'm supporting the fact that it's just a property name or it's a path. And then I have the whole logic here that gets a path, the parents, create the parents if they need to be created, and then set the value. That is actually pretty neat. And the ways that I will use that, I create the payload that I'm going to send to the AI provider. So I have some logic to get the messages and so on. And then I say, if streaming, then I can do a payload, xInsert, and then streaming true. Or obviously I could say streaming, because that is a Boolean. And so in this case, I decided to put the streaming true only if there's streaming, otherwise I let it by default. But I could also do something like that, and that will work also very nicely. So this little API here, xGet and xInsert, make working with JSON so much more convenient, while we'll use the full power of the CRD API. And so that is what I like with the support name and this kind of things, is pragmatic first and then elegant second. Okay, so that will conclude our utils chapter. And now we can talk about our examples and our test best practices. And in fact, they are relatively related. Let me explain. Okay, so the way that I see it is that the examples, obviously for documentation, but it also gives the opportunity of testing the API ergonomics. And then the tests that are unit tests or integration tests, they are going to allow us to do the testing of the API implementations, the behavior. So in many ways, this is testing the facade, and this is testing what is behind the scene. And obviously the example here, one of the key things is documentation, and often it's the entry point of a library. So usually when I learn a new library, I like to go to the examples and then see the code there, and that is often a good entry point of how to use it after the README. So in my library, what I like to have now, I like to have little storyboard like that, where I have C for chapters, can be other things, and I have a number padding like that. And sometimes I might have a dash and another number here if I want. This is a README, so I make sure that my README that I have over there, the example, always compiles. That is a nice way to not have that out of sync. So I just copy paste, but at least I make sure that it compiles. And then people can run the README like that. And then I have the one for conversation to customize the authentication for the adapter kind, the chat options, and the model names. And in my README, if we go down here, we have the examples. I copy paste the C00 readme.rs. And then I have the more examples where I'm going to describe a little bit each library and their goals. That is the way I do it. Now, that doesn't have to be done like that. As long as there is good example for the common use case, and with whatever consistent naming convention you have, you are good to go. Now, the second best practice that I have is that I don't use unwrap. So that again is what I explained in my Rust error best practices. I don't use unwrap, and I do not use as well anyhow. And so that is for my example as error, but the same thing for my test errors will be the same thing. I use a result, void, and then the boxed-in error pattern. And that gives me as flexible almost as anyhow, but then it's progressive to my production error way of managing things. And the reason why is because unwrap, if you have one unwrap left in your code when you copy paste or whatever, then your application will actually crash. And the whole point of Rust is to build robust code. And so if a naive mistakes end up by crashing a thread somewhere that we didn't realize for a while, then it can be a big problem. And anyway, it's a bad pattern because it's not the way to do it in a production code. So what I like to do is having the result, and I don't do type alias or define anything in this case. I just do main result void of boxed-in error. And now I can use that as much as I want. And usually most of the question mark. So if we go there, we have the await, and that will work in a seamless fashion. And then even for the OKR, I can have OKR and give a static string or a formatted string, then the question mark and everything will work. So it's very flexible to use this pattern. So that is what I have. And my goal is to try to be as instructive as possible and to show the flow. So in this case, I have the flow, which is a question, the chat request, the client, the print option to be able to print something. And my goal is that the user should be able to go to the terminal and do a cargo run dash example and then C00 readme. Yep. And in fact, when I'm coding, I have a cargo watch like that, where I do the quiet, the clear, the exec, and then I do the run, the quiet, my example like that. And that allows me to go very quick and to be able to have a feel again of the ergonomic at the beginning of the development of a library. And in fact, I'm going to say something here that perhaps some will disagree with, is that at the very beginning of a library, I focus more on the ergonomic of an API rather than testing the behavior. That looks a little bit crazy. But the point is, at least to have the core of the flow of the API that I want to have and to have it right. And for me, the examples, because I put myself in the head of a user of the library, it allows me to really focus on the ergonomic of the API. And then I make sure it works. And then eventually, obviously, I write my unit test or my integration test. And for all of this here, I have some alias, the sh alias on Mac, such as I don't have to type this long command line. So for example, here in my ZSH file, I have a function like that I can call, and I will just do, for example, in our case, I will do a CWE, C00 readme. And that will start everything and will do the quiet and then the example and so on. That is what I like to do, and sometimes I just do alias when it works. This one I had to do like that, so it works better as a function, but you use it the same way. And then that's it. So that is my conversation here, to have a conversation with the AI to change the auth resolver, to make a custom resolver for a specific adapter config here for OpenAI, and then the kind, the chat option, and everything. So I have all of this there. I try to add comments. Can always be better, but some is better than nothing. Okay, so that will conclude the example side of things. And now we can go to our test best practices. So in Rust, we have two types of tests. The first is a unit test that we put inside our source files, and that allows us to test the public APIs as well as the private APIs and private modules. And that is very powerful because now we can test the inside of our implementation as deep as we want without making anything public, without doing some weird contortion. And then we have the integration test, which goes to a folder which is named test with a S, and then we put our files inside. And that allows us to test from the outside, so the public APIs in this case. So now, the way that I like to have it for the integration test is I like to have all my files like this, my test. I have my support as well, often, which allows me to give some helpers that I can reuse there. So that allows me to have my test code much clearer because now it doesn't have to repeat many of these common things. Then all my test files start with test with a S, underscore, and what it tests. In this particular library, because I have the concept of providers, I decided to have a prefix like that, which is P like provider. So like this, all of my providers are organized like that. So that is the same type of test, and that is the providers that I'm testing. Because later I might have other tests that are not really provider related. So if we go, for example, to the OpenAI implementation, we see that we have our test chat simple, okay? Test chat JSON, so I prefix with test. Those are Tokyo tests because they need to be async. If you don't need it, don't put Tokyo test, you just put test. And then here I'm calling my common test. Usually I don't have that for other type of libraries, but in this case, by design, there's the same logic for all of the provider, and then the only thing that changes is the model name. So in fact, if you look at this one, we have those guys, and then we have the same thing for Olama, and so on and so on. And the reason why I'm doing it like that is because when I do the testing, when I do the implementation, I do it provider by provider, and then I check that it works on everybody. So with cargo test, we can do cargo test, and then we can do a test, and then we can give a first filter, which is going to be the exact file name. So that will be our test p underscore OpenAI. So that will run everything. So usually I do that to develop that. And then we can do a test. We're going to see that later. The prefix of all the function I want to run, all the function exactly. So I do a text chat, and that will test all of the test chat inside this file. Or I do a test stream. Or if I want to test a specific function, usually I have something like that, which is simple, okay. And in fact, what I usually do is something like that where I actually don't do a cargo test and go a cargo watch, -q, -c, -x, and then I do that, and then I do the no capture here. That is what I do. And in fact, I don't type that all the time because that would be silly. I have that sh function that allows me to either say CWT and my test function. So that's good to go across all files or unit test or whatever. Or I do a CWT with a test file name, which is actually test with a S usually. And then is the prefix that I want to test. Or if I just do a CWT, it will do a cargo watch or nothing. And in all of these versions, it's going to do the no capture. And the no capture is very useful because what I do is I do a cargo wash test on something, and then I do the print. I make sure that everything works fine, and then I change the print to asserts, and then I'm okay. That is the way that I do the whole workflow, and it works like a charm. And this function, honestly, I change it over time. There's probably a smarter one to write, and I use a lot ChatGPT or LLMs to help me creating that because I have no clue of what is that, but it works well. There's a one, I guess, is the one up here. That's the only thing I can see. Okay, so that is the way that is organized. Now, if we go and look at the test here, we're going to have the import and so on, and then here I do the mod support. So the thing which is important in Rust is that every file is their own crate in a way, so or their own binary or whatever. So you need to re-import the mod support. And here in this case, only for, again, this library, because I have this common test, that is not something I use for other libraries, but in this case, it's fitting. So I put the common test that I'm repeating all the time everywhere, except the model name, inside there. So this way I can just have the function. Then I do the result best practices that I have with the boxed in, all very flexible and everything we need. And then I have the model. So all of them will look similar to that. Now, in the implementation, in this case, what I do is Tokyo test because it needs to be async. And my naming convention is test underscore, what I want to test, and then the variant of what I want to test. And then am I testing the OK or the error, dash error at the end. So in this case, I do the test chat, simple, just simple. And I do the test chat, JSON. And both of them are OK. And in this case over there, I do the test chat stream, simple, capture content, capture all. And again, I repeated that in all of those because for these libraries, that makes sense. And so that means that all the implementation that I would have put there is actually in this file. So if I go there, I see all my chat test over there, and then my chat stream test. That's the way I organize it. And again, the content of this function should have been there if I didn't have this pattern, but again, for this specific library. So now, how do I organize the content of my unit test? So I have, in my comment, I have region, so that is the code region of VS Code, and then I have section, like that, with a dash dash. This is just best practice. And then the first section of a test is always a setup and fixtures, where I define the variables and I set up things and I seed the data. So often I have a seed underscore that I'm putting in my seeders. When I start the first test, this is just one, I do it inline, and then eventually when I reuse it often, then I put it in my seeders. Then I have a section where I actually execute whatever I'm saying that I'm executing here, that I'm testing there, and then I do the check. And now is a cool thing because when we did the cargo watch and so on, what I have at the beginning in my check is I have actually a println. So I use a RustNX VS Code extension. I have a little debug print, and I prefix my debug print with that. This way I can always search them across everything and see if I have any leftover, and then I delete them because I make sure that they're not in the commit. And then I can do a chat res. And that with a cargo watch is amazing because now I can just code over there. I can just do a cargo watch, the CWT of the test, the function, exactly what I want. And then I can go there and just work on the adapters that I want. I press save, save, save. I see the print, print, print. And then when I'm happy, then I put the assert. And obviously when I'm debugging, I either keep the assert or I do a new section and I'm going to say debug print. And then I put my debug print over there. So that is the way I do it. And it's very fast to develop because very iterative. And then you don't have to worry too much about threadings. And if you develop something event-based and everything, you have the same practice for everything. That is what I do for most of my function. So this is what we have for test. Simple. For the JSON here, we just test some token. And then we test the content to make sure that it's a JSON content. So that is a mod JSON. Now, sometime in this case, I take another variable because Olama has a bug right now where if we do a mod JSON, it doesn't send back the token. It's no big deal because it doesn't crash anything, but the check that the usage.totals, that will be none. So that is one thing that we have done here to make sure that we can have in our test OpenAI be a little bit more flexible here. So that is basically the practice that I have in these kind of things. In the helpers, we have some macro rules. That is an ugly one. It's not necessarily a good one, but it's one that allows me to get the property of a struct, assert that it's not known, and if it is, it's going to throw an error, which is going to be a should have, and when we stringify the field. So that's nice, such as we don't have to do always OK or everything. And then again, because we use boxed in, it's super nice because that will work very nicely, and then it will return the value that we took. So that is just ugly, convenient things, and again, its support is always private. So don't feel bad about doing pragmatic, ugly code. We can clean it and make it elegant later. And those are convenient helpers. So I'm using helpers here rather than utils and support because that is just a bag of other things. And then I just extract the stream end, which is something I use a lot in the command test. So that is what I do. And then the last one that I do is kind of this seed pattern. And again, it's more like, it's not a pattern, it's more kind of a convention. Where I have a seed chat request, simple, and that I put the seed, all of the seed there. And I use that a lot also when I do database testing or whatever. I have my seeders, such as I don't have to repeat that everywhere. Okay, so I think that is going to finish this one. Actually, one little last thing that I wanted to say is that sometime for values, I prefix them. So for example, if we wanted to test the result, I would do a fx return total tokens, for example, or something like that. So when I do the fx, that is a fixture, and that is something that I can use below here to either create something and then check it or whatever. Okay, so that was pretty big, but that kind of concludes the integration testing. And now we can go to the unit testing, which is basically the same kind of pattern. We're going to have the setup, the exec, and the check. So that doesn't really change. It's where we put them that change a little bit. And to be honest here, I focused on the integration test for my genai, and it's still early in the development, and not really on deep unit test. There's two strategies in unit test, or testing in general. It focuses on the percentage of coverage percentage. And you say, obviously, higher percentage is obviously better. So let's go and write everything. And if you write a function without a unit test, then you're not a good developer. See you later. That is possible. The other option is to say, well, let's be pragmatic, moreover at the beginning, when we are going to do this smart coverage. It's not about covering all the functions. It's more all of the paths that are likely to break or that needs to be revalidated all the time. Now, that being said, there's some unit tests here that I should be writing. That will be probably one of the code here, so it might be already there, is in the utils. And specifically on this one here, where the take and then the insert, there's opportunity of quite a bug. Like this one cannot really fail. Yeah? So if I go there, this one is so simple that it could fail here, I guess, and fail here, and eventually it should be tested. I'm not saying it shouldn't be tested, but I wouldn't write the xget first. I will use ChatGPT to write it. But what I want is to test those two, and especially the insert. And so the way that I will do that is I have my little convention here, so I still have the things. And that is very familiar to Rust, and I'm going to use my VS Code Rust 10x extension, which is start everything with 1, and I have the test module, I think, something like that. So I'm going to test the 0.1, and that basically do the config test. So that is the way in Rust to do unit test, and that will define inline a modded test with a S. We could put it in a file, it would be the same thing, or we can put it there. If it's too big, might be a good idea to put in a file over there, but usually you inline them inside the code. And I like to put them in a section such as the whole thing get collapsed, but that is just me. Then I still have my best practice here where I have my error type alias and my result. The reason why I don't have that here, that will work also very well because the only thing we care is result of void anyway. We don't care about the box din. But sometimes I like to do the use super star. Then that might include as well the error on the parent one. And so this way I make sure that everything matches very nicely because that will override it. And then when I do the error, the result will match this error. And I won't have a bad surprise. So that's why I do it this way. And then as a function, very similar to what we had before. So I'm going to go there. And I have in my Rust 10x VS Code extension, I have ATF, which is basically the async function with comment. And that will give me the thing. So I will do a test value insert OK, for example. And that here I will do let. I might do a fx value perhaps. And then I will do a JSON. And in this case, I give a JSON and I can say, token. I don't know why I say token, but 3. And that will create the value. And then because we have the JSON probably in super, that's why it didn't complain. And I like to have the use super, so like this I don't have to think too much on stuff. And then in this one, I would do a fx value. I need to make it mute, obviously. That wouldn't be fx in a way. That will just be value to be correct here. And then I will do a x insert, and that will do that. And I will do a happy world. And then on the value, I will do something like hello. Press save. That works. That is probably because the trait is added above. There's a clippy that complains. It's probably because we don't have the question mark. And in fact, what I would do, that is how I would do the fixture. I would do a fx value, not value, I guess. And I would do hello. And then I would take that there. That should work. And then I would check it. And now the question is, do I use the xget or do I actually get it manually? That is a debate on both sides, but on this one, I'm going to make it easier. And I'm going to say actual value equal, and I want a string, and I'm going to do ValueExt get, and then happy world. And in fact, I'm going to do like that. That should work. And we're testing quite a bit here because we're doing the insert with adjacent path, with that, by the way, won't work like that. And then we're doing this one there. And I will do an assert equal, and then I will do the actual value probably as str, and then I will have the fx node value there. So that should work. Yeah. Then I will probably check the tokens as well to make sure that it didn't get removed, for example. And then the way that I will do that, I will do a cargo watch test, and I'm going to do that. This hopefully will work. This one test that pass, and this one. So the problem of CWT is that it will test everything. So you could write something else or another kind of run to test only the unit test, such as you don't have to test and see everything else outside. So that could be a good one as well. And you can make the CWT better for that. But here, that's it. We passed it. And the cool thing with the cargo watch is if we do this and we want it to say one print value, and then we do the stuff here, press save, that will recompile and restart it. We see it there. We're happy. We remove that. We have the assert and everything works fine. So that's it. That is my process. And it's actually very efficient. And actually this one, I can commit it. So the way that I will commit this one, I have an alias as well. So I have a lot of alias because I don't like to type, or I don't like to type things long. I will do a git commit. That will be a git commit -a-m. I have a best practice to do dot because it's a minor. I will say unit test and it will say first xt insert. And then that's it. That will give me that. And then I check that it's there. And then typically I do git push origin or ranges. And then that's it. So that is, we did actually a commit live. And that will conclude this episode. In the next episode, when to async, when to do sync, project files, and versioning. Big thanks to Crabnebula for the sponsorship. Until next one, happy coding.